Alrighty, good morning everybody. First off, I'd really like to thank Altair for hosting this event and the sponsors for supporting it. I think that I've been a long-time believer in small, product-focused user groups. I've participated in a lot of them over the years. I think this is a great opportunity for us to get together and talk, mostly to our colleagues. So I really would encourage everybody to try and to get to know somebody here. And if you see somebody standing off by themselves, make a new friend, because we all need one. So, hey, I was kind of low-key last night, but today I'm going to be ready. So I got the glasses, I got the hat. So I'm ready to go. So when I put this, I think most people have had the experience where you wake up in the morning and you go, what was I thinking? And that's really what happened with this presentation. When I submitted it, I thought, oh, this makes perfect sense, this is going to be great. And then I got to the point where I was actually putting together materials, and I was like, oh, that's not so easy. So really, it's a little bit less structured than I would normally give a presentation, but I think there's enough material here for everybody. So thanks for your forbearance. All right, so we have a service. If you got a service, you got to have a service slide. This really kind of captures what our HPC service is all about. First and foremost, what are we here for? We're here to support our engineers designing aircraft. And we use our hardware, we use a combination of HP servers, InfiniBand from Mellanox, and Panasas storage. We've got a couple of data centers that helps us with disaster recovery, and we have to have a solid disaster recovery posture. It also brings the computing a little bit closer to our users that are spread across the US. You know, one thing that's really quite a bit different from us, from a lot of other IT services within Boeing, is we are a pay-as-you-go sort of service. That ends up, and we're really low barrier in terms of new users coming on board. That's both a blessing and a curse. Really, all it takes is a manager's signature, and you can start using it, create an account, and start using our service. And our limits are fairly generous. You can get up to about 10% of one of our clusters without really any pre-arrangement. We do serve all of the business units within Boeing. We used to be focused on BCA, but now we support the defense and space folks, as well as the research and technology. And another thing that's kind of different about our service is we do have end-to-end responsibility. We do the whole thing, unlike other places where you'll typically pull a server from this group, some storage from this group, system administration from a different group. For better or worse, we're it. So we ended NERA recently. Last year we retired our Northwest data center, which is located in the Seattle area. And so I took a look back, and I wanted to kind of capture and share with you what our history is. And Boeing has very, very deep roots in HPC. Boeing made strategic decisions back in the 60s and 70s that computation for both design and for engineering were important. And so Boeing wrote a lot of their own CFD codes very early on. This shows kind of where we came from. We were obviously a Cray shop for a long period of time. You know, we were a little slow on the uptake on clusters, quite frankly, but we kind of got back there with a vengeance. We did dabble with an SGI system for a brief period of time. And one constant over the last decade has been Panasas storage, which has served us pretty well. So what are the typical applications in our environment? Well, I think this pie chart at the top actually kind of underrepresents CFD. I think our arrow is actually more like 3/4. This was a snapshot. And with a fair amount of, with structures being a distant second. I don't really think I need to say much more about that. We have a wide variety of codes. Some are locally written. In aerospace, we have a variety of codes. We have NASA written codes, we've got Boeing written codes, we've got commercial codes. In the structures environment, we're pretty much all ISV codes. And I don't really know what the electromagnetics folks use, but that's fine. So, hey, that is one pretty plane. So I can't claim to be impartial, but it really is. But what it's here for is to really tell you about how many different things ways CFD plays a role in designing a plane like this. So it's not just about the wing. It's really about both large and small scale modeling of airflows, things like cabin air and flows, and those flows, the position of things as small as the position of pitot tubes and other sensors. All these things have a CFD element. So we're using CFD both on very small scales and very large scales, and pretty much everything you see here is run at least partially on our HPC service. So I've talked in the past about the value of HPC to Boeing and kind of the return on investment, but I think really this statement from one of our major BCA customers really kind of says it all. I think the most important thing to note here is the date, which was 2006. So HPC had already converted how we design airplanes a decade ago. And if anything, we're more dependent on it now than we were then. So, you know, it's no longer, this is one of the challenges we have, is to really communicate to our management that HPC is not a frill, it's not an extra, it's not a nice to have, it really is essential to designing aircraft. So, secrets of our success. What the heck? I should keep these, but you know, they're very strategic, but you know, most of them are common sense. So we're pretty careful about what hardware we pick. We make sure our utilization is high. We do a lot of automation and focus on configuration control, and I'll talk about that in just a second. You know, we're not really focused on performance as much as price performance. I mean, we want both, but when push comes to shove, we want to deliver the most bang for the buck. And so that's maybe a little bit different emphasis than some other places. You know, we're not CFD experts on my team. We're not structures experts, but we know people who are, and we know how to talk to them. And so that's really a key to making sure that we understand where things are going and maybe what requirements we're going to have to deal with in the near future. Root cause analysis. This is one that we take on ourselves. Anytime we see a failure, even on a single node, we want to understand why. And the reason for this is we want to build a health check to address that. We do a lot of health checking. We're using Bright Cluster Manager to provision our clusters, and it has a very nice framework for doing health checks, and a nice reporting interface for reporting and notification interface. So anytime we see a failure, we look for a root cause. It's really tempting to just say, oh, we'll wait for a reoccurrence, but it's not a good policy because it's going to come back to bite you at the least convenient time. So anyway, so we do a lot of health checking. We run health checks on every job. We have health checks that have never failed, but you know, it gives us a great deal of confidence that the nodes are what we think they are in terms of configuration. And one of the things it does is by squeezing some of the busy work and the noise out of maintaining clusters and chasing after these phantom failures, it really gives us a little more time for user support. And so we really do try hard to, when we do engage with users, to really let them know that give them a quality experience with regard to support and hopefully give them a positive feeling that we're a partner they can trust. So as I said, we aren't the experts on applications, but we know people who are. Boeing has kind of a structure where we're the platform delivery folks. We have a completely different organization under a different IT VP who's responsible for managing all the applications. And so we make sure to reach across that organizational divide and work with them for the key applications so that we know what's coming, we know how to help them make good use of our environment. Well-defined, redundant, Department of Redundancy Department. Anyway, yeah, service definition. This ends up, scope creep is a deadly problem in our space. Everyone says, oh, you guys can get something done, can't you do this for me? And this is, you know, you have to say no. I mean, this is just the reality. And this is particularly problematic at Boeing because we've done a lot of consolidations to local data centers, and the HPC guys were kind of like the catch-all for any local functions that needed to be done. Hey, I need a file server. Hey, I need some Linux desktops, whatever. All that stuff ended up being quote-unquote HPC. And so when people come to us, they're like, well, of course you do this because my old admin used to do it. And we're sometimes we say yes, but a lot of times we say no. So we do want to innovate. We're somewhat cautious in what we deploy and how soon, and we certainly aren't bleeding edge on things. But you know, we're an HPC. We have to follow new technologies. And finally, this one didn't really seem like a big deal, but the more I thought about it, the more we had to shove it in at the end here. Is we're a rated service. So we have both a cost pool where all the costs associated with HPC go, and that gets distributed based on usage to our customers and that chargeback mechanism. And being a rated service really has protected us from a lot of reorgs and similar things where they might have just said, oh, well, we'll just fold you in with whatever. That has ended up being an ace in the hole that we really didn't appreciate going in the past, but I think it has really been a key factor for us. So I said the couple items that I thought were really important were automation and configuration control. So you know, we're using Bright to do our provisioning and health checks. We basically look at any manual processes we do and say, what can we do to get us out of the business of pointing and clicking and whatever we need to do to address the user request or whatever issue it is. So we really look at all manual processes and see what we can do to squeeze the labor out. And in a lot of cases, you can't automate the whole thing. You still need somebody to at least make one more click, but even partial automation is a win. And so that's one of the ways that we're able to support as much hardware as we are with as small a team as we are. And as I say here, it only gets harder because you plink off all the easy ones really fast, and then you got the really nasty stuff behind, which ends up always being account administration and storage administration, because those are the ones where you either have users or you've got passwords, you've got people who want more storage than you can give them, you've got a whole bunch of things. You got to have people in the loop, and it's always a pain. Configuration control. So we've done a lot of work, and I really got to credit my co-lead, Greg Sekas, for his unyielding drive to address this. But we put all our local code into RPM packages so that we can track and manage it. We've also put a bunch of stuff in. So configuration control is more than just the OS. It's also the hardware you're running on. So we have a bunch of health checks to check firmware and BIOS settings on the nodes. We'll have a node go out of service, HP will go fix it, they'll replace the motherboard, BIOS settings will be all different, firmware might be different, things could break. So we have health checks to check BIOS settings, to check the firmware versions, to check everything so that we know that we're back where we need to be for that node. We started with the idea of we were going to put everything in RPM packages. Pretty soon we had multiple clusters keeping track of what RPM packages went where. Became a challenge. We introduced Zipper, and now slowly but surely we're driving everything into the Boeing Git repository. So again, we're trying to use automation and these health checks to squeeze all the manual labor we possibly can out. And this allows us to first and foremost, provide reliable service, but also reduce the number of support calls, reduce the labor, and good stuff like that. So, speaking of innovation, one thing that we did fairly recently, this has been kind of a multi-year project, is we've been doing air-cooled systems for between 8 and 10 years, air-cooled clusters. And we were hitting a wall on a couple things. One was space in the data center and cooling capacity in the data center. Another was the fact that we were looking at technologies such as computational GPUs and higher wattage parts from Intel. And we didn't really have a good way to deal with those in an air-cooled environment. They were just going to blow way past the limits we had in terms of that the data center levied on us with regards to power per rack. So, so we partnered with HP on this, and they were very eager to have us do a proof of concept and eventually adopt this for full production. So this kind of reflects about half of the total system. On the bottom, you see one of the boards. HP refers to them as trays. There's a couple servers here. It is water cooled. There's a primary water loop and a secondary water loop. So the water flows through a wall and vertically in these chassis. Each of these blades at the bottom has those heat pipes connected to a place where the heat transfers. And so we're dumping the heat directly from the CPUs through those heat pipes to primary loop to building chilled water. This is a lot more efficient than heating the air and then using crack units to pull the heat back out. It's probably even more efficient than what Switch is doing with both hot aisle and cold aisle containment. It's a cool machine. So we have used this as a platform for GPUs. We've only really kind of dipped our toes into GPU computation. So but this enabled us to do it and gave us the option of providing that in a reasonable footprint. So, all right, this is just a typical day, typical month. The blue at the bottom is node utilization, green is idle, purplish, periwinkle is jobs queued. A couple things to note is you notice the steepness of the decline on the periwinkle color. We burn jobs off pretty fast. Unlike NASA, we don't have the week-long backlog. In general, most users can count on getting a job or multiple jobs started in a day, sometimes in minutes, sometimes in hours. Some of the things you see here are places where, I don't want to touch that, where you've got purple over green, and that's because users there's been a user limit encountered. And we do enforce user limits. Again, I said about 10% is our default limit for how much a single user can grab. So you had cases there where the user was over a limit, and that's why even though we had some white space colored green, we didn't use it. But that's pretty high utilization overall. So I mentioned one of the things we do is make good choices, if not great choices, in terms of the tools we use. And so I really thought about this and what makes a great software tool. So first off, it's got to be reliable. I mean, it's just kind of a basic ground rule. It needs to be scalable. You need to be able to grow it as your requirements grow. And efficiency and performance are part of that. It's got to be reasonable about the resources it consumes, and that actually helps enable the scalability. It needs to be flexible, kind of out of the box. You got a bunch of use cases, and it addresses most, if not all of them. But it also needs to be customizable. You need to be able to, at an individual site, make it work as you need it to. So scriptability is something that I really love. Being able to do basically anything you can do in a GUI from a command line is a huge benefit, and we leverage that really heavily. From my perspective, maybe I'm old school, but I really prefer a flat file full of directives over an API, because you can unit test and you can say, well, we're going to build this tool that's going to feed all this stuff to Bright or feed all this stuff to PBS, and you can look at it before you actually invoke it. And so for me, being able to control things via the command line or via directives is really important. Extensibility, I think, this is something else that we, there's always going to be requirements for administering an HPC system that the vendor didn't predict. And so you need some mechanisms of extending it. And finally, you need vendor support. I mean, if that's not there, well, sometimes you're lucky, sometimes you're not, I guess. So one of the things I wanted to emphasize is that we really try and make our tools work together. So these are what Greg refers to as the 4 pillars of our HPC software. We got PBS Professional, Bright Cluster Manager, SUSE Linux, and DCV for remote graphics. And I think the best way to address this is, so what I'm trying to do is kind of show how these pieces work together. When we first brought in remote graphics, we brought it in as it had dedicated nodes. We were hand configuring them. We had a separate broker to distribute the sessions. With phase 2, we said, no, we've got tools to do this. And so if you look at the DCV down in the corner, you'll see that Bright provides some functions for you. It's doing the configuration of the nodes. PBS we're using to schedule those resources. So when people want to run a DCV session, they submit a PBS job. And we leverage the fact that we're already scheduling lots of other nodes. Why not schedule this type of node as well? And then finally, we use control groups to enable safe node sharing for multiple users, giving each user a well-defined partition of both cores and memory. So that's kind of that. So what do we use? We are at a PBS Pro conference. We do use some PBS Pro features. We did a major rewrite of the prologue and epilogue. There was some really old, dusty deck that I wrote way back when for prologues and epilogues in Perl. We rewrote everything in Python last year, added a lot of additional resiliency to the code. The stuff that we use it for is node cleanup, C group creation, and managing a specific shared directory we use at our site. And then we also use the prologue and epilogue to trigger the health checks that we write and Bright runs for us. Hooks. I love hooks. I think it's a really amazing model. We asked for user extensions to PBS or site extensions or site exits for a long time, and this has been just a boon for us. We really don't use that many variety. We use some Q sub hooks, we use some run job hooks. And we do a exec job hook or two, but they're really nice. It's really a nice thing to hang a bunch of stuff off of. So we're doing chargebacks. So we do allow users to specify an alternate charge if it's not their default. We make sure that that's correct. We wrote our own license management hook to deal with a bunch of problems that we had with regard to license management. That same hook actually does rate limiting so that one user can't basically busy out the PBS server by just hammering us with thousands of jobs. We had a very typical scenario where one user would submit 10,000 jobs, and then QSub and QStat would just kind of drag because everybody's grinding through those 1,000 jobs and saying no. So we're really looking forward to the feature of whatever it's called, job affinity or job grouping, where, hey, this job by this user got rejected, reject the rest of them. So I think that'll really probably reduce the need for this, but I don't know if it'll eliminate it. But the license checking has been really good and really solid for us. We do some GPU management and then MIS bookkeeping. So we do have DynPBS. I wrote that a long time ago. It does what it needs to do. We have just a few queues, but you still have to load balance between them. So all DynPBS does is kind of look at the job mix, look at the priorities, and say, we'll throw a few more nodes, E-cores actually, over to this particular queue. PBS accounting log, that is our basis for all our chargebacks. Everything that we do downstream to recover costs is based on the PBS accounting log. And then, as I mentioned, we schedule multiple kinds of nodes, our generic compute nodes, GPU nodes, and the remote graphics nodes. All right, so what about these other things? So our management is really excited about this idea of commercial-like services. Well, from my perspective, we've been a commercial-like service for a long time. We do watch our costs, user experience, but what really overlays all this is, what about the cloud? Isn't that the solution? Well, maybe yes, maybe no. Turns out Boeing has already kind of figured out that for the vast majority of the work that's done on our HPC systems, it is not suitable for a public shared cloud offering. But nonetheless, there's still a lot of pressure and still a lot of perception that the cloud can somehow magically solve some problems. So when in doubt, become a cloud yourself. So I used to be pretty shy about this, but I'm not anymore. We are a cloud. So if you look at the 5 NIST criteria for cloud: resource pooling, broad network access, on-demand self-service, rapid elasticity, scaling, and finally, measured service. There's a lot of different interpretations of these things, and Boeing has its own slightly different one, but we really are an internal platform as a service engineering cloud. So, maybe that'll help, maybe it won't, I don't know. One thing I think that's really important when you're having these discussions, and they're inevitable discussions about cloud, is, isn't it cheaper? And so I think it's really important to understand what the costs of delivering your HPC environment and services are. As I said, we have had a long history of doing chargebacks, so we know what it costs per node hour to deliver our stuff. But I can see in a lot of other organizations that might not be nearly as clear. Probably my single biggest piece of advice is figure it out. Do a spreadsheet. Understand where your costs are flowing, what the real cost of delivering your service is. Because if you don't have that number, management's going to assume that number's really big. In our case, you look at this, and if you look at that, 80% of our cost is either hardware maintenance, or the data center to house it. So yeah, you could squeeze that 20% maybe a little bit, but there's really not a lot of wiggle room there to reduce costs. And if you're at any sort of scale, yeah, we won't get the same prices that Amazon or Google will get on servers, but we'll get close, and those guys still have to make a profit. So we really are very competitive with the outside world in terms of providing HPC at a reasonable cost. All right, so looking forward, we're going to continue on our strengths. So what are our challenges? Well, staffing is always a challenge. We do have a very small staff. We really have a lot of single points of failure, which worries me. I try to communicate this up the chain, and not a lot happens. So everything's fine right now. So no need to worry. But I've been with HPC. So I've been doing HPC. That timeline, I started the timeline in 1980, and there's a reason. Is because in 1981 I started doing HPC for Boeing, and so I've had a long career here, and I want that to continue. I think Boeing will always need HPC. I don't know what it'll look like in a decade, but I know it'll be specialized, and I know they'll need people who have specialized skills to address it. Budget and capital, we're in a position where it's tight. I mean, it's one of my biggest frustrations is there's never been a real effort to dial back and say, this is the amount of HPC we need. Instead, we are driven by the budget we have, we work within it, kind of works. And as I mentioned, service definition and scope creep, no good deed goes unpunished. You really got to be careful there. All right, so initiatives. Boeing has a major data analytics initiative. We're still trying to figure out what our role is there. Seems like a really natural fit. We deal with big data, we got a lot of cores, we got some GPUs. But that's a completely different org, and we're still in discussions on that. Containers, we're doing everything we can to not use containers. We really don't want to go there. Who manages the containers? Who supports them? We don't want to be the ones doing it. So that's a scope creep kind of thing. A lot of new storage technologies coming out, NVMe and all the local high-speed storage. You know, our nodes are diskless. We don't really know what the future is. And then finally, there's HPC accessibility. This is something that we've been talking about for a decade or more, is just HPC is not user-friendly. And I think that's still the case today, and honestly, I think it'll always be the case. I think it's just a very tough nut to crack. A little bit of history, we had tried Compute Manager as one solution to this. And for a lot of reasons that I won't go into, I'll be happy to talk to folks offline, we decided it wasn't a good fit for us. And when we made that decision, well, Altair wanted to know why, and I don't blame them. And I think it was a combination of things. They want to make sure that the product is as widely applicable as it can be, and they also wanted to support us as a customer. And so we had pretty much made up our mind that we weren't going down Compute Manager. I mean, it was a hard decision to make, but we made it, and we weren't going to go back. So we had some discussions, and Altair asked us, what the issues were and what we saw were the challenges. And to my mind, there were a lot. I'm really not a fan of web interfaces in general. The web browsers change out from under you. There were a lot of support issues. We weren't really happy with that. But the biggest single issue was we just didn't get any traction with our users. We put a lot of work into deploying Compute Manager, and when all was said and done, we had a dozen or so people using it after close to a year of production. And we couldn't do it. So again, I talked to Altair about this. I gave them some feedback on what I thought. And then they came back a week or two later, and they said, we think we got something for you. And I'm like, huh? I thought I was done with you guys. Anyway, hey, I wanted to listen. I wanted to understand what they had to offer. And so what they've done is kind of turned Compute Manager inside out and the relationship with the desktop and the server. And they've done some interesting stuff. So, when they asked me what I thought the issues were, I thought one of the issues with Compute Manager was it still was hard. Even though it was a web interface and everything else, users still had to have a mental model of where things lived, how pieces fit together, and for the people that we were trying to target, that was too much. And so, when I talked to Altair, I said, we really need what users want. What users want is a magic button to make this all happen for them. No, push it over here, pull it back from there, none of that. Just magic button, make it happen. And like I say, I gave them that as the requirement, and I thought I was done. But that's not how it worked out. So instead, they came back and said, we got something. That's your magic button. And I'm like, okay. So So this is a project that we've been providing feedback to Altair on for probably about a year. I lose kind of track of time, but that seems about right. So, I mean, the real focus was, you know, from my point of view, is what would it take to make this the best product for Boeing, right? And because in general, my feeling is pretty strong that if you make a product that works in our environment, it's gonna work other places too. And so, anyway, so we've done that. We've partnered with Boeing has a long tradition of supporting and partnering with its suppliers. I mean, this is absolutely essential in the aircraft manufacturing part. But we've also had a long history of doing it in the HPC environment and in IT in general. So at this point, I'm going to yield to Dario, who's going to, I believe, give you a demo. So anyway, I'd be happy to talk to anyone who has questions about our experience, and after the fact, feel free to grab me. Thank you.
Hello, everybody. Good morning again, and I'm here actually to get this from where Jim left it, and to talk a little bit about PBS Access desktop, our service that sits on the desktop computer. So we know we are here, and we know that HPC is used to improve many aspects of people's lives. PBS Access Desktop is in the business of letting people actually having more time to enjoy their improved lives, and especially the engineers and scientists that work with HPC. As Jim was telling, let me take a step back actually from that. So HPC engineers people who use HPC to do engineering and scientific discoveries do use a lot of tools. Web browsers, they deal with a lot of data. They have nowadays even mobile devices, and they do a lot of scripting, and they have a workstation on their desk. So we thought that actually having a web browser-based interface was a good fit for Boeing. And, well, you know, like, things don't always work the way you intend them to work. So we had like few technical challenges, but most of all, what we found working with Jim, Sergio, and their team is that what really didn't work there, and that was really what, at least in my opinion, didn't work, was that the software didn't map the organization. The Boeing organization is, there are people who manage the hardware, people who manage the applications, and people who use them. And somewhat this part didn't agree with our web-based offering, with Compute and Display Manager. So speaking together, so where do we go from here? What do we do to actually make things better? And what we came up with is this thing that I'm about to show you, and if you haven't seen already. So I'm switched here to my Windows desktop. Does it show full screen? Oh, okay, yeah, the screen is better. I'm looking at those at the sides, they are kind of, but the ones you are seeing are right. So engineers, mainly in the CAE domains, that where Altair has most of its installations, do use these things here that are files that exist on their desktop, maybe in a shared file system. And with a web-based interface, they would have to open a web browser, maybe log into it, explicitly transfer the input file over there, click on submit, and wait for the job to be submitted, computed, and then they have to retrieve the result in some form. Our interpretation of the magic button was actually to give to integrate with the tools that are already familiar for the users. In this case, the File Explorer from Windows, and give them the possibility to have a context view of what they are able to do with the file. In this case, the file has a .inp extension, so we know that's an Abacus input file. When you look at one of these files, you see that they are actually OptiStruct input file because of the extension. So when you want to submit an OptiStruct, basically you just click a couple of times. We still didn't remove all the clicks. We're working on that too. What's happening behind the scenes is that PBS Access is taking care of logging in through SSH to a login node, transferring the files over there, creating a temporary staging directory, and is waiting for the job to finish. And this one in particular should take just a few seconds, and then the files are delivered back in this directory that was just created for it. And so this is actually the output of the solver. That's the spontaneous applause.
The magic happened.
Yeah, the magic happened. So, and basically this is more or less it. Let me show you a little bit more details about this tool. When you have to do something more complicated, there is the possibility actually to access if the resolution is not helping me here. Okay, let me do a small change. Is better? Yeah, a little bit better. Okay. You have the possibility to also call up a fully featured job submission interface. Let me put just some random number here, and then submit the job in a similar way, and you can see the status of the job. And while the job is running, it'll take a second. There it is. While the job is running, you can also see in a very familiar way through Internet Explorer what your job is doing. So in this case, this file is being pulled from the HPC environment. PBS Access Desktop takes care behind the scenes of handling this file listing and file movement. And what we do here is that we use, again, SSH, SFTP to grab the file and the list of files, and then we translate that into using WebDAV in a way that can be used from the Internet Explorer. Basically, what's happening here is that we have this file system here, my cluster, that is actually a virtual file system that shows the jobs that are running. This means that it's a running job, call it like this. This is the job ID that is running over there, and this is a folder where you can click in, and that's the job running directory. Of course, when you have a web interface, you can point the web interface to the exactly same HPC server, and you can still use the web interface to do more or less the same things. Though I don't expect users to do that as much once they have this tool on their desktop. But we are in the phase of discovering that if they really like this or not. But so far so good. How the applications are integrated was mentioned before. That is important for the tools to be extensible because not all sites are the same. And so we support a way to integrate applications with this tool, whether desktop or the web. And the integration is done via scripts that tell what aspect and what parameters should the input interface have. And this is this file here that expresses what are the input file. We have another file that tells how to use that input, how to map that to an actual submission command. And at the very end, you have the executable script. And this is what actually gets executed on the HPC execution environment. One other aspect that actually came up during the work with Jim and Sergio was that one of the cultural clashes is that this model that we propose for integrating applications was in competition with what they already had. So they already had a full set of libraries of commands and utilities to submit jobs and to submit them accordingly to how their environment works. And so we also, as part of this project, are extending the way we integrate with applications so that we can actually support like a way in between, right? Totally writing your application and just relying on what you have from the command line that is like supporting custom submission commands. So in this case, the integration happens because this abacus, some parameters here, returns a job ID, and we capture that from the desktop interface, and that's our submission tool. So basically what happens in this case is that this abacus command is executed on the HPC environment, and the output is basically the job submission. And I think that's more or less it. Behind the scenes, there is a lot of automation, especially with respect to the files selection, because the interface for submitting a job is very limited. So when a user clicks on a file and says, I want to run this solver on this file, well, the input might be more than just that file. So there are what's normally called include files, and what we're planning to do is to develop application-specific automations that will look into whatever file is selected, gather what all of the other data needed for the computations are, and transfer them to the remote HPC environment. So that the user doesn't have to struggle with remanding to selecting files and so on. Yep, that's all, folks. And of course, if you have questions.
Yeah, if you have questions for Dario or for Jim, can you just clean this up and show us the short version of, hey, this is all you have to do as a user? Sure. Again? Because I think when you went into a whole bunch of other stuff,
yeah.
Which was not something you don't have to do as a user, you might have gotten confused. So you are now a user again.
I am a user. I am selecting my input file and saying, oh, I want to run this with OptiStruct, and just click, and then I just have to wait for the results to be back.
Okay, that's it. Thank you.
I have a lot of questions, but I'll just ask
Start
one.
with the first.
Okay, yes, I will.
Then
I'll
we will
start
get
with
to the
hardest.
others.
So I imagine that Jim's organization, like mine, has a really strict sort of corporate security posture. So I'm curious about all of the pieces involved. You said it uses SSH. Does it retrieve the SSH? Is something SSHing results back to the Windows system, like a push-pull? And are there any services running on the Windows PC necessary to do this?
So this is the authentication screen for PBS Access Desktop. This is where you define your HPC complex. And the very first time that you use this tool, you have to specify username and password. And we use them to SSH the remote HPC environment and generate a certificate. If you click the little box, skip this the next time, we generate a SSH certificate on the HPC environment, and we store it locally. So the next time we don't have to ask you a password. The other way that we can do that is that we ask username and password every time PBS Access Desktop needs for the first time to access the remote HPC environment, and those are the two protocols that actually satisfies Jim's organization. We are looking into other ways to handle this so that actually you could give, you already have SSH certificates and you give them to the users and you instruct them actually to put the private key in place and the public key on the where it has to be. Just the other thing is that we use just SSH in this build here, so everything is SSL basically encrypted, and when we push files and retrieve them, it's always using that channel that I believe is actually kept open the whole time, right, Sergey?
During job execution, it goes to execution post, and the rest of the time we cannot load anything.
So what happens when you submit a job, then you reboot your PC before the job is complete? Will something go and check?
Yeah, the current mechanism is based on polling. So there is this, the desktop client is actually a service that is on the desktop machine. And we configure that to start up at the login of the user and stays in the machine and runs, and every once in a while pulls the remote login node and pulls the results back. We are looking at scalability, because when you have hundreds of users, we have to see if this mechanism still works. Actually spoke with a few of you already during these days to see if there are any concerns with massive amount of SSH connections going to a login node. Actually, the number that I got back are promising. They are way better than what I expected, but nonetheless, we are looking at also implementing an alternate mechanism that is based on push. So an alternate architecture for achieving the same would be to install something on the login node or some service, and that would be the PBS Access server that serves both the web interface and this push channel towards the registered clients. And in that case, we could also, if that was the case, get rid of the SSH connection and just use our service. But I think that for the sake of flexibility and making happy multiple sites that have different needs in terms of security and access, we will probably continue support both SSH in this way, and when it's the case, like a server-based installation that works probably better architecture when you want to run both the desktop tool and a web-based tool. Yeah.
I think the gentleman asked the question, maybe I missed the response, but you don't normally want the files returned to the PC all the time. Is that going to be an option? Because you could have 50 gigabyte files from 200 users. You don't want them all clogging the network coming down. Right?
That is true, and that's the next step. Big part of what we are thinking as so let's say that dealing with user, we switched thinking from PBS jobs, and we started thinking of the data flow, and the compute part is a piece between your input file and your output file. And as part of this process, we actually came up with the idea of developing an architecture that is able to orchestrate the transfer of files. So you could start, for example, from your desktop, and then at submission time tell that you want the results delivered, I don't know, to an AWS S3 bucket somewhere, or the other way around. And so that will be part of this. It's just we need to do one step at a time. So we start from this that is operational and probably very, very well suited for CAE organizations. But then there are also things like, by having this tool sitting on the desktop, we can also understand whether or not the file you're clicking on is on your desktop or already on a remote file server. And in the case the file you are selecting is already on a shared file system, we don't even transfer it to your desktop and to the HPC environment. We just tell to the HPC login node, if possible, go grab the file from there. And so that's we are well aware of the dimension of the CAE and beyond CAE file problem, and we are trying to do everything that is possible actually to make that easier.
Okay, time for one more question.
Yeah, I've noticed that you have to enter username and password. Do you have any plans to support Kerberos?
Kerberos, not currently, but it's the authentication mechanism is extensible. So if you want that, yes, I can put it in the roadmap. And by the way, how many people are using Kerberos? So probably it will be.
Or multi-factor is another thing where it needs to respond asking for a token.
Yeah. Yeah, the authentication and security is a very sensible subject, and we started from this model that is very simple and very targeted to our first customer for this, but we know that there are multiple authentication. For example, for the web interface, we already have a supported way of integrating Compute Manager with Windows environments where inside the Windows, a trusted Windows environment, you don't have to put username and password to get to the job list. We just fetch whatever is the authenticated user on the Windows machine. And so that could potentially be extended to this tool as well as other mechanisms.
Thank you very much.
Thank you all.
And-
And if you want to see more or need more information, I will be around.
Thank you. Yeah, so Dario will be in the back, and come attack him during lunch or during the breaks.